morning, everyone. And thank you very much, Alistair, for the kind introduction and the opportunity to speak with you all today. So, as Alistair mentioned, today we're going to be talking about the results of a study that we did on what Australia's future 7-star homes could look like and what would be required to get there. Today I'll set the scene a little bit first up, and we'll look at an introduction of the National Construction Code, where we're headed with NatHERS and the future requirements or regulatory requirements for residential housing in Australia. And then we'll dive into the study that we did. So we'll have a look at the results that we got for Melbourne, and we looked at quite a few different homes and variations on those homes and the performance of them for Melbourne. And then we went around Australia and looked at a range of different climate zones and how they impacted the performance of the homes and the building fabric that we selected for those homes. Finally, we'll go through some of the thermal bridging assessment that we did, and we really wanted to compare lightweight and brick veneer homes and the impact thermal bridging had on those wall sections of those homes. And we'll talk a little bit about some limitations of this work and where we think the future is in a number of additional studies that could be done in this area. So Alistair's already covered off on most of this, so thank you, Alistair. I don't think I need to talk much here. But yes, over the last couple of years, been working heavily with industry, especially the timber industry with XLAM, CLTP, Big Ash, doing a lot of testing, performance verification testing and product development, especially in the CLT and glulam area, as well as studies such as this on energy efficiency and sustainable design for the Australian market. So there's a few of the companies that we're currently working with here at Melbourne Uni and in our group. So to set the scene of why we did this study and what the drivers are, well, Australia from a high level is committed to a reduction in emissions, as we all know, 26% by 2030. And a large portion of those emissions are associated with buildings. So the energy use in either constructing the buildings or the operational energy of those buildings. Within those buildings, 42% of that emissions associated with residential energy use. So that's the energy to heat and cool homes. It can be electricity, natural gas, wood stoves, but it's a huge portion of the energy we use in Australia is in these residential homes just to keep ourselves warm and cool depending on the climate. So the low energy buildings trajectory aimed at reducing these greenhouse gas emissions, and they provide recommendations to ongoing changes to the energy efficiency provisions in the NCC. And we've seen a number of updates, especially in the commercial side of the NCC of late. And the next iteration, we're expecting a number of upgrades to the residential side of things. So currently, there's 3 general options that we're likely to see or thinking we'll see variations of in the next iteration of the NCC in 2022 for volume 2. So initially when we began this study, we thought, okay, 7 stars is going to be the mandate. That's what we need to reach. It seems that might not necessarily be quite as stringent as that, with 3 general options being considered: a minimum of 7-star NatHERS, which we'll talk about NatHERS in just a moment if you're unfamiliar with what it represents, or they're talking about maybe raising the thermal comfort standards to 7 stars, or maybe a balance between these 2 solutions. So the other really important thing and big change that we're likely to see in this next iteration is not just an energy efficiency provision for heating and cooling, but more of a whole of home assessment that enables maybe a slightly poorer performing house to offset energy use with maybe on-site renewables such as solar PV. So that's where we're anticipating things are going. And I guess it's a large driver for this study that we did. So if you're a little bit unfamiliar or not certain, NatHERS is the nationwide house energy rating scheme. So all new houses required to get a minimum of 6 stars under this rating scheme. It's important to note the bounds of this rating. So And NatHERS assessment models only the heating and cooling energy in the home required to keep it comfortable. So it doesn't model any other electric appliances or your pool pump, or if you've got solar PV. None of that makes any impact on the current NatHERS star rating. There's limitations to this software, such as currently thermal bridging isn't included. So a steel framed house and a timber framed house, as assessed in this software or in this rating scheme currently, will score the same star rating. So thermal bridging is not currently included, but it's likely in future iterations to be provided for. And we'll talk about that right at the end of the presentation today. So you get a star rating out of 10 stars for a home that's assessed, where 6 is the current minimum for compliance, and 7.5 is industry best practice. So that's a high performing home will score 7.5 stars. Now, where we're thinking we will see the future of the NCC is at around the 7-star mark. So that's generally how we scoped out this study, is how can we build 7-star homes. So we're very, very thankful to the Forest and Wood Products Australia, who sponsored this study that we've been performing over about the last 9 months and are just in the completion phase now. So the scope of the study that we did, we investigated the impact of different building fabric options. So we had a look through different wall systems, floor systems, glazing elements and their frames, and insulation levels throughout homes throughout Australia to see what impact they had on the star rating or the performance that we're likely to see depending on different climate zones. So we assessed most major climate zones. We didn't do a high humid summer, warm winter zone right up the top there, but we generally covered off most of the other zones where we have the most highly populated areas in Australia. So Brisbane, Sydney, Canberra, Melbourne, Hobart, Perth were sort of the main focus cities and climates for this particular study. We had a look at different combinations that would be required to meet 7 stars, and we'll run through those with you today. And we also had a look at thermal bridging and how much impact it has on the performance of a wall section for a typical residential home. So that was the scope of our study. And we'll dive in now and have a look at what we assessed and what we found. So first up, let's have a look at the homes that we looked at assessing, because they're obviously really important on what outcomes we're likely to see for energy efficiency. For the homes, we selected 2 key homes, and HIA kindly provided their standard home for assessment, and we'll have a look at their plans for that home in a moment. And we did 3 general baselines for that home. So hopefully it's not too complex a table, but here, why don't we get the pen here so we can draw on a little bit. So the 3 different major baselines was the standard home with a subfloor system, so a timber subfloor with R2 insulation, a standard home with a concrete slab on the ground and low E windows, and the same home again, but now with a waffle pod slab and some double glazing. So this last one was our high performing HIA home, I guess. And these other 2 variations looked at one with a subfloor versus one with a concrete slab on the ground. Now, for each of these, we chose relatively common metrics or building fabric selections for the wall. So we had just a brick veneer wall with R2.25 equivalent insulation. We had single glazing in the first 2 options, aluminium framed with some low E glazing elements in the living spaces for this first option, and in all sort of bedrooms and living in this second option. And we had R4 ceiling insulation in all 3 options. Now, these formed our baselines, of which we did variations after that to see the impact of different variations. On the right-hand side here, we made up a home that we called the Lynvale home, and it was based on a typical volume builder 2-story home that we're likely to see. And that had, I guess, similar elements to our other baseline, with the exception that we chose relatively high performance glazing for this home. And we did that because we needed to get a baseline of 6 stars, a minimum compliant home. Due to the fact that this was double story and quite a narrow home, we needed to upgrade some of the building fabric to get to that minimum as the baseline. Now, each of these we assessed either just in Melbourne or around Australia. So this first option here with the subfloor, we assessed just in Melbourne. The middle two options, the other HIA homes we assessed around Australia, and our volume builder home here we assessed just in Melbourne to get a feel for things. So having a closer look at the HIA home, it's probably fairly representative of what you'd see for a single level volume builder home as well, maybe slightly smaller than the average home that's getting built now, but nonetheless a 3-bedroom with an open plan kitchen, dining, family area, formal lounge and attached garage. So we ran this model for this home and we achieved 6 stars. Now that's our baseline, and all the results from here on will be compared to this baseline. So as we make changes to the glazing or the ceiling or any of the other aspects, we will see how they affect our 6-star rating. For our Lynvale, or our 2-story narrower lot home, as you can see, we've got 8.45 meters as the width of this particular home. We again achieved 6 stars with the following inputs. And you can see in this particular one, we've got a 4-bedroom home plus sort of a multi-purpose theatre room or living room, so a bit bigger than our HIA home as well. So for each of these homes, as we said, we did some sub variations. So we changed some different elements of the home to see how things, what results we got. And we started off because most of this, the original thinking around this project was, let's see what the impact of different wall selections could have on the performance of our home. So we selected a range of common but also higher performance walls, as you can see here. So maybe let's not get bogged down in too much of the detail here, but we selected some brick veneer walls with some different size studs, a cross laminated timber build-up from that XLAM provides, some lightweight direct fix options, and some higher performance, I guess more unusual solutions to see how they'd perform, such as some 140mm studs, some reverse brick veneer, so the brick veneer is on the inside of the house instead of the outside. Pretty uncommon, but nonetheless a good solution for thermal mass. We looked at a few other ones with Hebel as well. And the important things, I guess, are the overall R value for the performance of the system, of course, and the overall thickness can have implications on the construction as well. So they're the wall types. Let's have a look at what we saw with the results. Now, I'm going to take a little bit of time to explain this figure because it's really important for everyone to understand what this figure represents, because I'm going to have quite a lot of them. So we're going to start with the left-hand axis here. And on the left-hand side, I have variation in the star rating. So we remember our original house scored 6 stars. That was our baseline. So if we have variation that's positive, we're getting greater than 6 stars. So let's take one example here. We're going to take brick veneer at 140mm. That's achieved 0.1. So that's 0.1 above our 6 stars. So that's an improvement on our baseline. So what this tells me is 140mm stud improved our star rating by 0.1 stars. That's these blue column lines on this graph here. So we can see a negative rating would mean, in actual fact, this house wouldn't quite be compliant without upgrading something else, because we'd be at 5.9 stars. Now, LWDF is lightweight direct fix. It's just a 90mm stud with fibre cement cladding, a lightweight typical wall system. We have aerated concrete, 75mm Hebel here, for example, as well. And what this graph is showing us is what variations we had when we selected different wall types on the star rating. The other thing that we see on this graph is from the orange and the grey lines. Now they represent, as you can see at the bottom here, heating energy requirements and cooling energy requirements. So orange here, we can see in Melbourne, obviously we have much more heating energy than cooling energy, which is generally down here. So we saw a lot more heating energy as we'd expect. And as we move from the left to the right, we're seeing better performing wall systems. So on the very far right-hand side, reverse brick veneer was our best performing wall system, and it achieved 6.3 stars from the results. Now, initially, this was a little bit disappointing for us in the study, because a reverse brick veneer wall's generally a pretty high performance wall, and to only see 0.3 improvement in the star rating wasn't maybe as much as anticipated. And we'll come back to why that's the case later. But so far, we didn't see huge variation depending on what wall types we selected for Melbourne. We did the same for the Lynvale home and generally saw a pretty similar trend, but we saw a greater importance on thermal mass now in our Lynvale home with our reverse brick veneer, our CLT, our larger stud systems starting to give us star ratings of around 0.5 or 0.4 stars, more than 6.5, more than 6, I should say, so 6.4, 6.5 stars, which was good to see. Principally because two things: they got a bit more thermal mass on the inside of the home, which is always a good thing in these temperate climates such as Melbourne, but also because they had a bit greater insulation overall, such as 140mm studs obviously got more insulation in the wall, so we saw better performance. Nonetheless, we didn't see drastically different performance changes for our Lynvale home versus our other homes, versus the different wall types. So from there, we moved on to another key element in our homes, which is glazing. For glazing, we selected a range of different single and double glazed systems, some with low E, some with aluminium frames, timber frames, or UPVC frames to assess the difference. We assigned some approximate costs to these, and we'll come back to the costs a little bit later, but to see what impact these different glazing elements had on our standard homes. And what did we find? We found they actually had a large impact on the performance of the home. So on the very far left side here, you can see if we replaced our low E glazing with single clear glazing, we actually lost 0.3 of a star. But on the other hand, on the far right-hand side here, if we use some higher performance glazing, some double glazed argon-filled low E glazing, we actually achieved 1.1 stars, more than 6 stars, so 7.1, which is great. We've achieved our 7-star for the HIA home simply by replacing the windows with some high performance timber framed windows. Now, many of you will be thinking, oh, timber framed windows are a little bit more costly. Maybe that's not the best solution all the time. We'll come back to that, I guess. But often, or most of the time in this instance, timber and UPVC frames perform about on par. So if it's a timber frame system or a UPVC, they're fairly comparable. What we did find, though, moving from this right-hand solution here that was really high performance to this one, we had the same glazing in both these options, but we just changed the frame. So from this one, we had an aluminium frame that was not thermally broken. And because of that, we had enough conductivity through the frame that we actually lost half a star from that conductivity. So one of the findings that we can see from this is the frame is actually as important as the glazing element itself. So thermally broken frames or timber or UPVC frames are also very important in our selection. So we can see as that varies. One thing I didn't really mention is these lines here. So our orange curve, you can see that's decreasing. That's the heating demand. So as we improve our glazing throughout, we get greater performance and less heating energy required by the homes. And I guess between this aluminium frame and this timber frame, sure, we see the heating energy decrease a little bit, but what we see decrease more is this grey line here, which is the cooling energy. So that's the sun on the frame of the windows conducting through a lot with the aluminium versus the timber framed system. So at that stage, we had a bit of a feel for glazing and wall elements, and we decided to assess a number of different other additional building fabric options for each of our homes. So starting with our HIA home again, let's have a look at what we found. So we started with a few things regarding the roof. We looked at continuous roof, which is maybe a colour bond roof versus a tiled roof. We found very marginal differences in performance. We had a look at the roof colour, which again had very marginal, very minor impacts on the overall performance of the system. Moving on to flooring though, or the slab, we actually found that we could have quite a reasonable difference as we vary different aspects of the foundations of our building. So remembering our baseline here was a subfloor with R2. If we change that to just a concrete slab on ground, we actually got a performance improvement of 0.2 stars. If we improved the insulation of that subfloor to R3, we got the same improvement of 0.2 stars. If we increased our ceiling insulation to an R6 bat, we got another benefit of 0.2 stars. So all these things gave us benefits on our design. Other things that gave us much larger benefits, as you can see on the right here, was concrete slab edge insulation, which is obviously not common or almost used at all in Melbourne and more alpine climates, but nonetheless, it's good to see it would have a benefit on our performance. And waffle pod systems that had a massive benefit, actually, a 0.6 star improvement. And throughout this study, we found waffle pods were a good balance between having some thermal mass and some insulation. And we'll come back to some of those findings. We found somewhat similar results for our volume builder 2-story home, but we did find we were starting with a waffle pod here. That was our baseline. So all the other solutions performed poorer than our waffle pod, but it was the same trend as our HIA home. So based on those findings, we put together some, I guess, solutions for 7-star homes for Melbourne that varied either glazing or wall systems or ceiling elements in order to achieve 7 stars. So this is, I maybe won't go through this table in great detail. You'll, as Alistair will mention at the end, that this is recorded and uploaded later, so you can have a look through the slides. But in essence, we came up with a range of 7-star homes, most based on double glazed window elements with either improved insulation in the walls. So we can see here R2.7. We know that's a pretty expensive wall insulation bat, but it's one way to achieve 7 stars. And we got the first 4 options with a subfloor and better either ceiling insulation, wall insulation, or double glazing to some extent. However, we did find that we can also get single glaze solutions with either UPVC or timber frames to also achieve our 7-star goal. So we don't have to go to double glazing. It's not the be all and end all of 7-star homes, but we did have to have waffle pod slabs in order to achieve in these particular examples. If we didn't want to have a waffle pod slab, if we wanted a concrete slab on ground and single glazing, again, it could be achieved, but we had to go the best brick veneer insulation in our walls, and we had to also upgrade our ceiling insulation to R6. So obviously all our building elements contribute to performance, and it's a combination therein. We went from there and said, well, how far could we go? What's the best we could achieve in Melbourne? And this table summarizes the best of the best in terms of our HIA standard home. And we managed to achieve 8.2 stars with both our CLT and reverse brick veneer home system, some nice double glazed argon-filled windows, R6 insulation, and EDS insulated concrete slabs. So obviously not a common build, but it's good to know it's possible to achieve such high star ratings. So in summary, what did we find from this first Melbourne-based study? We found the Lynvale home, or our double-story home with a narrow lot, did not perform as well. We only got to 6.9 stars on most of these variations. And that's because we had less solar heat gain. We had no eaves on this home, and we had stairs connected to living spaces. So a lot of hot air was lost, I guess, in heating months to the upstairs zone as well. So less performance for this Lynvale home. The HIA home, we found wall systems were less important than glazing, roof, or floor systems. We found thermal mass did have a benefit, such as the reverse brick veneer, and we found that glazing was really important in giving us benefits to the overall star rating. We also saw waffle pod systems or better insulated subfloor systems were able to achieve 7 stars. So from that Melbourne study, we then decided, well, let's have a look around Australia at different climate zones and assess the impact. We did less variations for obviously for every city, but enough that we got a feel for what was important in each climate in Australia. So I don't think we'll focus heavily on this, but this is a summary of the assessments we did. We had 2 general models, our HIA home with a concrete slab on the ground, and our HIA home with a waffle pod and double glazing. Why we had two separate baselines was because we wanted one that was, I guess, a very common build and one that was a very high performance build. So our waffle pod double glazing was our higher performance baseline. So we went through some more cooler climates and some warmer climates, and I'll summarize the results for each climate so that we can get a feel for the impact of cooler climates and warmer climates. So let's start with cool to mild temperate zones. Here's our HIA home, our concrete slab on the ground, and our low E. Our baseline home got 6 stars in Hobart. And what happened when we varied things? Well, if we changed our brick veneer to a lightweight, say, fiber cement cladding, we had a very small reduction in performance. If we changed our floor system from concrete slab to a subfloor, we actually got a big performance boost of 0.7 stars. And this was because we decoupled our slab from the ground, which is a big source of heat loss. So subfloors were looking really good in these cooler climates such as Hobart. We saw, however, the same benefit for our waffle pod system, again, because it's decoupling the ground, maybe not to the same, well, not to the same extent as the subfloor, but still to some extent. What about our higher performance home? Now, our higher performance HIA home, a lot of the study was about different glazing elements. And we saw that most of the glazing elements we assessed, say double clear glazed timber framed windows, performed slightly poorer than our baseline, which was a higher performance glazing element. Probably the takeaway messages here are clear trends with subfloor, again, outperforming our concrete slab on ground. And low E glazing really having a massive impact in these cool climates. So low E meaning single glazed low E versus our double glazed element. So again, a big performance drop from single glazing versus double glazing. We moved on to Canberra and we found the results, I guess, spreading a little bit from before. So now we found that our subfloor was actually leading to a little bit of a decline in performance compared to Hobart. With much greater cooling energy requirements from that subfloor in Canberra. Otherwise, similar sort of results for our lightweight, and again, our waffle pod performed quite well. Again, the same trend for our high performance home in Canberra, with low E glazing having an even bigger impact this time, our single glaze low E, with a negative 0.8 stars compared to our baseline double glazed system. Again, the same sort of result with the subfloor, not performing quite as well as we saw in Hobart. So our final assessment we looked at for our cool or temperate climate zones was Melbourne. And I guess it was somewhere in between both Canberra and Hobart in terms of results, with subfloors performing a little bit worse than our concrete slab on ground and waffle pods performing well. So we can see some trends developing for sure in this assessment for both our HIA homes. So to summarize, for cool to mild temperate climate zones, we could definitely get 7-star homes, especially with glazing, as we've shown in previous tables here. We found waffle pods were a really good solution for all the locations assessed here, but the timber subfloors were starting to perform better in the really cool climates such as Hobart. And if we insulate them even better, we'll get probably deviation from the waffle pods to the subfloors, where subfloors will actually perform better than the waffle pods because they're completely decoupled from the ground. We found that double glazing added about a half a star of performance and up to 1.6 stars compared to a single glazed low E window. And we had less benefit in installing double glazing in the night use spaces than just the day use spaces. And we'll come back to that right at the end. The next assessment we did was more to warm temperate zones. So looking at Sydney and Perth. So starting with Perth, the standout issue we saw here was subfloors performing quite poorly. Again, with, as you can see, this point here, this grey point, the cooling energy was the key reason for that. So because we're not coupled with the ground anymore, the software is modelling as a lot of cooling energy required in these homes. We'll discuss the validity of that model and those assumptions right at the end, but that's the key reason we're seeing now subfloors starting to not perform as well as either waffle pods or concrete slabs as we move further north in Australia. For our higher performing home, again, a very similar trend. Subfloors actually derating our performance significantly at 1.8 stars. But again, most of the other results quite similar. Lightweight direct fix wall system, not quite as beneficial as the brick veneer now without the thermal mass. On to Sydney. First thing to note is our baseline home for Sydney, when moved to Sydney, actually scored 7 stars. So we actually got more performance from the same building in Sydney versus Melbourne. And that's simply because the climate's not so harsh. So the home performed better in this climate. However, again, we did see the subfloor derate the performance. We saw our waffle pod now actually performing slightly worse than our concrete slab on ground. And that's because we're seeing cooling being more beneficial in Sydney. So we've got more cooling energy required than heating energy. So now the ground taking energy out of the home is actually an advantage, not a disadvantage. And hence the waffle pod's no longer the best solution in this zone, but rather the concrete slab on ground is becoming a better solution. Again, a similar trend for our higher performing home. But one thing to note is our higher performing baseline HIA home actually scored 8.4 stars here in Sydney. So really right up there at really very high performance, probably in excess of what would typically be constructed or necessary to be constructed in Sydney. So to summarise some of the warmer temperate climate zones, what we found, yes, we can achieve really quite high star ratings. We found that timber frames or UPVC frames outperformed aluminium framed windows. We also found that we achieved approximately 1 star more for double glazing versus single glazed homes. We found that the subfloor, as we said, was starting to derate our performance, and that brick veneer walls performed a little bit better than our lightweight fibre cement lightweight clad systems. So the final climate zone we assessed was our warmer climate zone. And for this, we exclusively focused on Brisbane. And in this one, we looked a bit closer at our flooring systems. So we had a look at a range of different subfloors to really get a feel for what's impacting these subfloor results. So on the far left, you can see here a very open subfloor with R2 was a very poor performer at minus 2.3 stars from the baseline. So this would not be a compliant home in this instance. As we made the subfloor less open, we saw a little bit of improvement in the system. So as we're not letting drafts go under the house, we saw a little bit more improvement. Now, surprisingly enough, as we removed all the insulation from the subfloor in Brisbane, we actually found that the performance improved. And that's because now we're not trapping the heat in the home as much. We're actually allowing some ventilation underneath, and we're finding that we're actually getting a little bit better performance with no insulation. So it was quite a surprising result. And I guess something like what a Queenslander would have been constructed historically was more along those lines. What else did we find? We found that single glazing with clear glazing had a negative 0.5 star result, mostly due to solar heat gain. So we had a lot more solar heat gain through the glazing elements. We found lightweight direct fix was not quite as good as brick veneer, but we found that it didn't actually matter if we went to 70mm studs versus 90mm studs. We had the same star rating. So 90mm studs in Brisbane, probably not necessary in terms of the performance of the home. We found our waffle pod system performed poorer than our concrete slab on ground for the aforementioned heatsink reasons. Very similar results again for our high performance home, noting our high performance home got 8.4 stars, which is really good to see. So the final summary for our warm, humid summers. We found lower solar heat gain windows were more beneficial, most certainly, because we got less solar heat gain through the windows. We found that subfloors performed much poorer in these climates compared to our cooler climates. We saw a little bit of improvement in the performance if we double glazed our night space dwellings, so our bedrooms, because we're obviously having to condition our bedrooms at night. So that was good to see that we're getting more benefit now from double glazing these night use spaces than we would in the mild temperate climate zones. And we found we could achieve really very high star ratings. So 7 stars was not an issue here in Brisbane, that's for sure. So at that point in our study, we said, well, why don't we look at some other more interesting aspects of home design and see what impacts it has on the performance of the homes. The first thing we did was remove eaves. So we removed the eaves from our home to see what impact it had for each of our major cities. Now, we know eaves as designers, as engineers, as architects are a good thing, but how much of a good thing? Well, it depended where we were. In Brisbane, we found that removing the eaves actually subtracted 0.4 stars from our rating. But in Canberra, we found it actually made no difference. Although, yes, it increased our cooling demand, because we've got so much heating demand in Canberra, it actually didn't have any change in the performance. For Melbourne, we actually, surprisingly enough, found the same thing. However, for Sydney, we found the eaves were quite important. So it did depend a little bit, but based on our assessments, we found climates that were predominantly cooling climates benefited the most from eaves. We also ran a bit of a cost-benefit study for glazing, and noting these glazing costs were fairly approximate, but on the right-hand axis here, we have the cost of our glazing, and that's the orange curve, and on the blue lines, we have our star rating. So here we glazed either just the day spaces or the night use spaces as well to see what the performance benefit was, but also what the cost was. So I guess one interesting thing to find is here, we found that we got a little bit of a dip in the cost, and that's because we were only double glazing the day use spaces, but we still got very high performance for our home. So it's not really necessary to double glaze every window on the house to get high performance. If we choose high performance glazing for just the spaces that are being used the most, the living spaces, we can achieve quite a cost-effective solution that still scores very well, as opposed to double glazing every space in the house for a very marginal performance benefit. So it depended. As we said, in Brisbane, it was a little bit more important, but in Melbourne, we found those double glazing in the bedroom spaces was not as critical as the day use spaces. And as we can see here, this is the same for, so for Brisbane, as you can see now, from moving from just the day spaces to the bedroom spaces, we're now getting a big performance boost of 0.6 stars. So great to see, more benefit now from double glazing the whole house. But is it necessary? Maybe not, just because Brisbane, we already get very, very high star ratings here. So more benefit, but maybe not as warranted in these climates that are more or less intense in terms of heating and cooling demand. One more figure that I think is probably, if there's any takeaway figure you take from today, I reckon this one should be it. So as we said right at the start, we looked at these different wall systems and we said, well, it didn't actually vary the performance of our home that much. If we selected a really high performance brick veneer versus a lightweight direct fix, we got maybe 0.3, 0.4 stars difference. The reason because that was the case was because the heat's always finding, I guess, the path of least resistance, and that's not through the wall element, it's through the windows. So let's have a look at this graph. We'll focus first up on single glazing. So U value of 6.7, a normal single glazed window. The combined R value of a wall section with 20% window, so not even a high percentage of window, just 20% window, the combined R value is about 0.5 with that window. Now, let's say with a wall insulation value of 1.4. Now, let's say we make the wall higher performance, more and more insulation in the wall, up to maybe a really high performance wall here at 3.4 R value. So the wall's high performance, but we don't change the window. This is now the R value we get for the system. So reading it across, we're getting maybe 0.65. So a little bit of benefit in the overall system because the heat's still finding the path of least resistance through the glazing. On the other hand, if we choose a double glazed element and then we improve the performance of our wall, we actually are seeing more benefits now because the weakest link in the wall is no longer this really poor performing single glazed element. So takeaway message is we wouldn't improve the performance of the wall without improving the performance of the windows because it will always find a weakest link here. So that concludes the main scope of the study. As an add-on at the end, we looked at also some thermal bridging assessment for a typical wall. It's important to note that NatHERS does not include this. However, the ABCB intends to include some thermal bridging provisions in 2022. What they look like, I don't know yet. Maybe some of you will know better than I. But nonetheless, we had a look at what the implications were. We used two methods, the Australian Standards 4214 and the ISO 6946. Now, the 4214 is more common, obviously, in Australia in a commercial sense, but the ISO 6946 is more common internationally, a little bit more complicated, but also it has better correlation with numerical and experimental results, and it's a little bit more internationally recognized. So from a research perspective, the ISO standard is the preferred one. We took some standard walls. So we took a lightweight direct fix wall, standard section for that wall. We took a brick veneer wall, as we've discussed before, and we had a look at the thermal performance results of both those walls. So this left-hand side here is without thermal bridging. That's what the R value of these walls are. And that's based on what the current software would assess these walls as performing. Once we included the thermal bridging based on a New Zealand standard or the Australian New Zealand standard, we found that for a timber frame, this reduced down for a lightweight direct fix to only 1.8 or a brick veneer to 2.12. So pretty big reductions. But for a steel frame, we saw even more reduction in the apparent R value due to thermal bridging. Same story generally for the ISO standard. However, we saw greater reductions for the steel frame using the ISO standard. So we did a little bit of parametrics here and we said, well, what if the steel's a little bit thicker? Of course, we're getting more conduction and reduced R value of this system. And we decided to then say, well, what do we need to do to a steel framed wall to make it work equivalent to a timber framed wall? So I'm trying not to make this graph too complex. We'll just focus on the orange curve here, which is the ISO method. If we have a timber framed lightweight direct fix system, it has an R value, including thermal bridging, of about 1.95. If we follow that across to where a steel frame system would perform comparatively, we must include a thermal break of R0.5. So to get the same performance from a steel frame to a timber frame system, we need a thermal break of 0.5 using this method. Using the New Zealand standard, we needed 0.32. We know that's more than we're currently mandating at 0.2. For a brick veneer wall system, we found pretty similar results with a thermal break of R0.59 required using the ISO standard. The other way of achieving equivalency is simply adding more insulation. So the next thing we looked at is, well, let's just add more insulation in these wall systems and see what we need to add to a steel framed wall system to achieve equivalency with our timber framed wall system. Now, for the ISO method, we needed 5.2, R5.2, which is obviously excessive and not practical. So thermal breaks are the only real pathway forward to achieve equivalency here. We can't just add more insulation in our steel framed system. The same was found for a brick veneer system, or very similar results, I should say. So the thermal bridging findings, general summary was, we found a significant impact of both timber and steel for thermal bridging. So it's not just steel that thermally bridges, timber does too, but we can see almost double or significantly more impact for a steel frame system versus a timber frame system in terms of thermal bridging. We found that lightweight direct fix had a significant contribution was due to thermal bridging, and generally speaking, New Zealand standard 4214 was more conservative in terms of overestimating the R values compared to the ISO method. We recommended the ISO method based on the other research and the numerical correlations found with that method. We also found that realistically, the only way to achieve equivalency between steel framed and timber framed was to have either a thermal break or an air cavity continuous along that frame. So just adding more insulation wasn't going to solve the problem. Circling back to the study as a whole, this study found that 7-star ratings for the HIA home could easily be achieved depending on what upgrades we selected on glazing, the floor system, the ceiling insulation, or the wall insulation. And each of those had varying impacts on the overall star ratings of our systems, but it was achievable. We found the warmer climates in Australia were more readily achievable in terms of 7 stars with less required to be done. And as we put more into the building fabric, we actually got much beyond 7 stars. We found narrower lot homes had greater challenges in meeting this 7-star rating and would likely require a whole of home approach. So maybe solar PV offsetting their slightly greater energy consumption, simply because they don't have as much access to solar heat gain. Following from that, we found that passive solar design or passive design of the house was actually quite important. It's not just the building fabric that impacts the energy performance, as I'm sure everyone's aware, but also cross ventilation, the home layout, connection of stairwells to living spaces without a door also led to a lot of heat loss. So the performance of the home is also critical on its design. In terms of floor systems, we found both waffle pod and timber subfloors, when insulated to at least R2, provided really good solutions in our cool climates, whilst the concrete slab on ground solution started to become the better solution as we went into warmer climates. Finally, we found that high performance wall systems, so maybe double studs or 140mm studs, were only really of benefit if we use better performance glazing. So we would go to double glazing before we'd start upgrading our wall section, because as we've mentioned, all our heat is lost through a single glazing, regardless of what we do to our walls. So finally, some future work, as I've alluded to already on some of these. We really need to look a bit closer at these narrow lot homes. It is a bit of an issue for reaching 7 stars. We also need to look closer at these flooring systems and the coupling of the ground to the slab and the implications on heating and cooling demand. The CSIRO are currently investigating this to some extent and finding that groundwater actually has a massive impact on the heat demand, up to 40 or 50% more heat demand in Melbourne due to a higher groundwater table. So more investigations there is required because it impacts the home performance significantly. We also think a closer investigation into the performance of a subfloor and different type of modes and ventilation could be of interest. And finally, if we had a better access to cost data for all these building fabric elements, then all of a sudden we could start to optimize and come up with the best solutions for a particular budget or cost. Along with that, thermal bridging, we only looked at walls. We could also look at obviously ceilings, roof spaces, floor spaces, and the like. So that's all I had for you today. I'd welcome any questions. And thank you everyone for your time today.
Thanks, Philip. That was terrific. Let me just share my screen here for a sec. So we'll just take some questions, and we've had a number of questions today, so that's great. So well done. We've had a couple of questions around the orientation you used in your study. So one here mentions getting to 7 stars can be done with passive solar design and orientation. So did you look at different orientations rather than using just more expensive materials?
Yeah, most certainly. So on each of these homes and each of these locations, we did do a parametric assessment orientating our home at 90-degree increments. And we did see a little bit of performance variation in that. So often we get between 0.1 and 0.3 stars, depending on the orientation of the home. I didn't focus on that significantly today because often we're constrained by the lot of the house to which orientation it was in. But nonetheless, yes, I completely agree with the question. Orientation is important, and if we had a particular site, we could optimize for that site. But yes, I guess the range of performance we found was 0.1 to about 0.3 stars based on orientation for these homes.
And sort of with a similar flavour there, it's asked here about glazings on different orientation of the house. There's a significant impact on the heating and cooling loads. So how was that included in the study with the different glazings and the different orientations?
Yeah, most certainly. So this was included, I guess, to a fairly basic extent. So taking our Lynvale home, for example, we actually did select glazing based on the orientation of the glazing in order to achieve 6 stars. So we had lower solar heat gain coefficient glazing on our west face of our home. So we did a little bit of, I guess, bespoke analysis on that home. But yeah, most certainly, I guess for future work or and further iteration of this study would be to start modifying west or north or east glazing with different solar heat gain coefficients to see the benefits there. Yes.
Mm-hmm. Someone asked here about the performance of the UPVC windows compared to timber. How did that?
Yeah, it's a great question. We found that UPVC and timber were on par. So for most of the time, they were the same star rating result. So I guess in terms of looking at the results that I've presented today, I think you could interchange timber and UPVC with very minimal impact on the overall performance.
And did you, as part of the research, look at a battened lightweight wall cladding?
So the lightweight cladding system we looked at, no, we didn't look at a batten one. So it was direct fix onto the studs, the one we looked at, such as a fibre cement system. No, we didn't include a batten one in this case.
It's a bit of an interesting one with offsets. I'm not sure if you got the answer here, but do you know, will offsetting on site renewables also include the burning of firewood from sustainably managed forests for heating?
That's a great question. I would love to know the answer because I also have a firewood fire stove here as well. But no, I don't know the answer to that. I think there's a lot of questions I have about what the scope of this whole of home assessment will include and won't include. I think you're probably being optimistic if it would include that, but nonetheless, I'm very interested to see as well. Yes.
It's an interesting question. NatHERS gives higher star ratings for buildings with higher thermal mass. Building physics studies suggest that in a well-insulated building, thermal mass loses significance. So have you validated the way the NatHERS algorithm models the impact of thermal mass? I know we had this discussion around floor slabs as well.
We most certainly did. It's a great question, and Alistair and Boris and I discussed this type question in great detail. And I guess the short answer is no, we didn't end up doing that numerical validation. But no, I completely agree. As the house gets better and better insulated, thermal mass is less and less important. So it's a great question. I don't have the exact answers, but I agree with the general gist of what you're saying, yes.
Yep. And a question here about windows. Did you look at any triple glazing at all?
So no, we discussed this and we've been working with Ultimate Windows a little bit on a different project, and just the cost of triple glazing seems so prohibitive to assess that we just decided not to. Obviously we'll get, we're going to get performance benefits from it, but at what cost? And we didn't really see it necessary to reach the 7-star standard. So maybe if we're trying to get to 8 stars in these cooler climates, that would be something we'd have to look at. But for 7 stars, we didn't necessarily have to go that far.
Someone asks here, Philip, just about just explain a little bit about reverse brick veneer, what that really means.
Yeah, most certainly. So for reverse brick veneer, it's a great question. And I've seen some double brick comments up here under comments as well. But reverse brick veneer, we've instead of having our bricks cladding around the outside of our property, we have them on the inside of the house and the insulation on the outside of the bricks. So from inside to outside, we have bricks, insulation, a damp-proof course of some description, and then our external cladding. So what that means, or why that's, I guess, potentially a good thing, is because the insulation's on the outside of the thermal mass. So if we heat our homes either passively with solar energy, solar heat gain or whatever it may be, then the bricks or the thermal mass on the inside of the home retains that heat and radiates that heat throughout the night and keeps our homes warmer throughout the night. Whereas a normal brick veneer home, that thermal mass is on the other side of the insulation. So the insulation's, I guess, insulating our homes from that thermal mass. So we're getting much less benefit when the insulation's on the inside versus the outside. Although, granted, it is a really uncommon system and more of a theory than an actual practical use. And I did see someone's question saying, what about double brick? Double brick is fantastic if we have insulation between the bricks. But without, my home here's a double brick home, without insulation between those bricks, the R value of a double brick house is actually quite low, like 0.6 or thereabouts. So double brick, great thermal mass, but because the R value is so low, we're losing heat or gaining heat all the time through those systems. So a double brick system, not a great system without some insulation before. But if you're in a double brick home, there are retrofit options of spraying in insulation and the like. So that's my thoughts on double brick here.
Thanks, Philip. Look, we might have to draw it to a close here because we're just on midday, but we have had quite a few questions there, which we do record as part of the process. So I'll pass them on to Philip afterwards, and he may have an opportunity to come back to you with some of the specific questions for those people that have asked them. So thanks once again, Philip. Just before we finish up, I'd just like to remind you that all of these webinars are recorded, so you can go back and look at these or previous ones. Just go to that resources tab on the Wood Solutions website and click on the podcasts and webinar presentations. We also do, through Wood Solutions, a number of sort of videos about how we do different types of wood processes. I'd encourage you to have a look at those, the In Focus series, which is also on the website. And I'd just like to let you know that in 2 weeks' time at our next Tuesday Wood Solutions webinar, we have a presenter, Marie Johansson from RISE in Sweden, who will be talking about prefabricated lightweight frame walls and the current state of mid-rise in Sweden. So that will be a really interesting presentation there as well. So just finishing up, thanks once again, Philip, and thank you everyone who joined in today. We hope you got a lot out of that. It was an absolutely excellent presentation. Philip will be finalising his report shortly, and then Wood Solutions will be releasing some of the findings of that probably on the Wood Solutions website over the next month or so. So stay tuned for that. I'm sure we'll do some promotion on it when it happens. So thanks once again, everyone, and we'll see you again at the next Wood Solutions webinar. Bye.